Hello, Ewan. Hello, Aaron. How are you?
Hello, everybody. Hi, Dr. Killer. Sorry, I do not have a video again.
Oh, hello, Amir. Hello, Mir. Nice seeing you. Um, Thank you much for sending updated versions. I think you will consider.
I think you're muted, Dimitri.
We can hear you, Doctor.
You cannot.
We can.
You can.
Yeah, I think Aaron doesn't have.
Amir, you are muted. I'm not muted.
My volume was off,
Oh, okay.
so I couldn't hear.
I think you do not mind doing this little exercise of double editing of the result sections because they are like core part of the paper. And many thanks for sending these updates. So
You're welcome. I just didn't address one of your comments about changing the word screen polarization. So I will revise that in the next version if it's okay.
not a problem. It's better to some changes than no changes, and we are just doing incremental steps toward the plan. And in a regular year, we would prepare for Sanibel conference at this time, and then travel there. And through this practice at the conference, each thought and set of results become very organized and clear, and then paper writing goes much more pleasant. But due to viruses, we have a little change compared to traditional schedule. Also, in the last 2 months of the semester, I am assigned to teach 2 classes instead of one, so it will be. I hope it will not affect our group meetings, but better to get the most important part a little earlier. So let me also share information, and I can follow up with the link. The National Renewable Energy Institute is looking for a postdoc. So I'm not encouraging anyone to apply. I prefer we stay as a group, but just keep me informed. They have several calls for including quantum dynamics and materials. And so I really hope you will not apply, but they may just keeping you informed of this National Web Career. And Aaron may consider sending an application to have a leverage against Los Alamos. So if it will be more than one offers, one can negotiate and inform each other of the salaries and then get increased right away. So let me check if everyone is in the.
Excuse me, Dr. Killer?
Yes.
Yeah, I have a question. So, do you have any suggestion or idea about the internship in the relevant fields, for instance, quantum calculation or molecular dynamics or something like that?
Yes, I will talk one-to-one and share some options. Yes.
Okay, thank you very much.
I don't know if right now we are going to edit only the Google Docs documents, but just in case I've made everyone co-host. So if you need to share anything to everyone, and let me also share the links to the Google Docs document in the chat line of Zoom. So maybe we can check if everyone can access and edit, and then we'll go to like editing mode and wake up in an hour for a little discussion. So if you see that any of the documents are not editable, let me know so that I can quickly fix it. So are there any observations of lack of access, or everything is fine?
I'm good.
Okay. So I'm going to focus on these documents one by one, and approximately at maybe 5 or 10 we'll check if everyone is done, and go into little discussion of each part. And next week, I suggest all of us will make a little drafts of the discussion section. Okay. And if there is something to, if you need me, just raise the voice, because I may not see wavy hands or any text. Okay, I'm done with everything. Let me check how we are doing. If anyone needs more time, or you can go to the discussion. Even are you done with reading most? Okay, so maybe everyone is welcome to unmute and or unmute if speaking. So let's just go in the order as they are numbered. So first is the results for paper by and there is a question from Aaron. He's curious about specifics of how molecular hydrogen breaks onto pieces. Is it like two radicals or two ions? Is there any, is it needed for any interpretation? If needed, is there a way to find difference between these two scenarios?
I guess for the cleavage, we should end up with two radicals, but I guess I'm not very positive. I can do a beta charge analysis. So in this way, we can figure out the charge.
Okay, yeah, thank you. I do have a question which maybe it's for discussion, maybe it's not primary. How does H2 molecule receive the energy? Is it directly excited by a photon, or it gets kinetic energy through collisions?
in my opinion, we are just excited the sulfur molecules, right? So the hydrogen molecule should get enough energy from collision.
So it should be kinetic energy comparable to bond breaking energy, which like couple of electron volts.
Mhm.
So its kinetic energy should be like several thousand. Okay. Um, I wonder if this abbreviation should be more detailed, something like showing that the rest of sulfurs are here. Because while reading two sentences, it looks like from this configuration, from two sulfurs one get four sulfurs, like sorcerer stone is. Okay. Amir finds this phrase is not clear. I suggest words like a complete intact product. Even is it would it be applicable? And Amir, please comment if it makes you happy or we need more explanations from you.
Just maybe by language that was not clear to me. I don't know. Maybe it's my weakness in English, or the sentence was not quite clear.
But is it clear now, or you like what would you need?
Yeah, yeah, it's better.
Okay. This yellow fragment looks more appropriate for methods. It's all correct, but just to have results shorter. Figure 2 and figure 3, do they speak about the same trajectory or different trajectories?
I show different trajectories.
Is there a reason for this?
I guess it's just boring to show one trajectories, since we have already 8 trajectories in total, and others will be in supporting information. So
then when it's maybe a sentence or just a couple of words, then that those are representative trajectories that show most important features. But still for a reviewer, it looks like for lower energy excitation in figure 2, something went wrong, and authors try to hide some unfavorable effects and try to show different trajectory for different results. So it's much easier to add a comment, but ideally it's better to show the same to avoid unnecessary questions.
mhm.
It's really nice how you have written it, and in very short and comprehensive style, but for readers who need a lot of details, meticulous readers, maybe supporting information may have copy of this figure with each atom numbered. I'm not insisting, just let's consider it. 5 is likely intermediate rather than product. I could be wrong, but if it is in the middle, I believe this question is also asked by Aaron in slightly different context in the figures section. But it's for curiosity, not for criticism of how it is explained. in the product, is there electron density on hydrogens? Do you expect it, or do you have positive information?
I didn't check. I guess I need to double check the charge density.
Because the review that we were looking at on everything related to superconductivity, they try different materials in order to involve hydrogens in the properties of homo-LUMO gap, and they believe that it will give benefits in general. Other bonds across the periodic boundary conditions. We were chatting about it in private, but maybe one can add a comment.
Mhm.
Erin is asking about notations for panel E.
I guess it's closed.
Aaron, let me add my vision of how I interpret this figure. So just by common sense, if pressure increases, volume should decrease, as like PV curve in ideal gas. So these lines that go down, circles here and squares here, are likely volume. And when compressing, energy should increase. So open circles and open squares do increase.
In the figure, I have two teeny tiny arrows, which also indicates the symbol.
Okay. Aaron, does it sound convincing, or you would suggest more detailed explanation of symbols?
Yeah, I guess that all makes sense. But usually, whenever I see like if you have two axes and you have arrows pointing, I know I'm used to like one arrow pointing towards like the volume and then another arrow pointing towards total energy. So, you know, like it kind of, I guess I've never seen it where you specify that both of the like filled in circles are to one axis. That's why I was kind of confused. But yeah, I think if you just put it like, if you don't want to belabor it, just put a couple of extra lines in your figure caption.
Mhm.
Snapshots are chosen for most representative steps before or after reactions. Aaron is curious about the orbitals for intermediates and whether there will be any delocalization. And I interpret Aaron's question that if one wants to apply these materials for conductivity, superconductivity, the orbitals should be completely delocalized over the whole cell. And this, there is no guarantee that it will be seen, but if upon reaction, there will be qualitative change of the character of the homo-LUMO orbitals. If instead of being localized on sulfur only, they will take the whole space, it could be a relevant observation. Okay. And for the last figure, I know that this statement is wrong, but maybe one can find some better formulation. Like in your previous works, one was always it was always possible to say that upon irradiating the heaviest fragment, one goes to lighter and lighter fragment. Here it looks like it goes forwards and backwards, but maybe verbal explanation of this trend could help the reader. Okay, so any verbal questions to you? One, two, three. If no, let's go to the work by Mead. And please interrupt me and ask questions directly to him. I will go through what is typed here, but so Aaron is asking, what's the reason for increase of intensity? Is it higher intensity of individual transition between a pair of orbitals, or it is just adding together several degenerate transitions?
Hold on. Do individual transitions have higher intensity oscillator strength, or are there just more transition energy range? I guess I was going with the absorption spectrum at the time, and just the total trend was that it was going up. And as in you're saying, are there? Yeah, I guess I don't know an answer to that question. So maybe just looking at the figure.
In order to answer the question, you need to look at the data to the os strength spiral.
Yep.
Okay.
So what is necessarily wrong? Okay, the intensity of the absorb tends to increase the further away the orbital pairs are from the whole. Okay.
But do not look right now. We need to quickly go through things and then we can refocus.
Okay, I'll look there.
Okay. Amir finds the description here not clear. Amir, would you clarify what is not clear?
Each of which I didn't get that. What does that mean? Maybe can rephrase that or something like this.
Me, do you understand the suggestion?
Yeah, so the way I worded it was kind of suggestive, just saying, hey, we noticed this. Maybe water is kind of involved in some way in reducing the probability of electron transitions occurring. That was kind of what I was getting at. So I understand it isn't clear, but I was proposing it or suggesting it simply because that's what the data showed.
Amir, if there are two orbitals involved and each of these two orbitals have density.
Yeah, it's more clear now.
Okay. Yulin is asking, is there hydrogen bonding and what is general distance between water and monomer? Like, I understand it is a question for configuration of reactant before reaction. Like, how close is water just a spectator, or it comes to a distance, to noticeable distance to the monomer?
Well, it obviously has some interaction, but I don't know. All I would look at is the criteria of bond length, and so.
But you may measure the distance and place it somewhere, maybe in supporting information.
Okay. All right. Thank you. I'll look into it.
So Yvonne is requesting more specifics about redshift in the literature.
Okay. I can specify.
Yes, and you can do it here, and later on it can be maybe copied or in more detailed revisited in the literature in the introduction section.
Yep.
Okay.
Curves.
So according to you, something is not perfect in this sentence.
Yep,
So,
I can see it.
like the word before excitation looks
Yep.
very unusual here. Like redshift occurs after excitation.
Yeah, I see that. I don't know how that's.
Just try to reformulate.
Yep.
Okay, let's go further. So here, it is clear that you mean the transition energy, but from the writing, it doesn't. It is not clear.
Yep, I can specify.
So some suggestions from you. It's really great to see these equations, but later on you have text in them, and it's hard to edit. So consider to have equations separately and text in the editable form. And also, it looks like you are mimicking the style of organic chemistry journals when they have two sets of data, figures and schemas, schematic diagrams. It is a legitimate way, but I suggest as an option, if we do not use schemas and use only single set of equations, both from mathematical and chemical equations. And then if we follow it, it would be much easier to have only one line for such equations, like one arrow and one line, and then text. So instead of having it like a big object that you describe it, have it maybe only one line that alternates with verbal explanations.
Are you saying like the structural formula, like C6H12 or something? Like use those, or simply have the same figure but just organized in one line?
I would do. So having only one each, chopping it on one line objects so that we can put text between them. If it makes sense.
Well, I could just not get rid of or just ignore the middle stuff and go from beginning
No.
polymer.
Right now it is one graphical object.
Yeah.
It's maybe a two.
Oh, okay. Yeah, I get what you're saying. Yeah. Yeah, I get it.
Now we have a question from you. How does the polymer breaks onto X and Y? What's the difference between X and Y? Like if you look on the chemical structures
Yeah.
here, can you explain?
Yeah, so the fault in our thing is where I have the lines drawn, where the brackets are on the very top line. Those bonds technically break early on. And so I had to kind of signify that our polymer was breaking up into monomer units. And I wasn't sure how to specify that exactly. But the goal was to say that there's multiple monomer units. It's the same molecule, but then it would break into further fragments. This is just my first attempt, but
I kind of see what you are telling, but for my poor in chemical background, it seems to me that X and Y are absolutely identical.
Yes, that is on purpose because they're the same monomer unit. If you look above, it's a dimer, which is 2 units. So
Oh, you wanted to say, then you need to put brackets, the brackets before and after. So you want to say that it will be oligomers of different lengths, right?
no, well, I'm trying to signify that the monomer unit at this point, but maybe that's a bad, representation or bad mentality. The brackets indicate it's still like a chain, it's continuous, repeating. In my case, I was just trying to say that a single molecule of X and single molecule of Y came from that original polymer chain.
Even, does it make sense to you?
Okay, though, wait a second. So what is your model? Is your model periodic? Does
Yes.
it correspond to polymer?
Yes.
Then what's the meaning of monomer here?
So the point is to, what I'm breaking up in fragments is the monomer unit. So, okay, what you could do is literally everything have a bracket of N around it because there'd be multiple units of this. But the chain, when it's in bracket format, is designated with those brackets, right? So if we break it up, so it's not a polymer chain anymore, the brackets have to go away. So that's why they're gone or they're missing. But I still needed to specify that they're like multiple units, even though they're not a chain.
Okay, but then you do not need to have two. You can say just like X monomers.
Okay, yeah, I can.
Okay, yeah, now I see what you want to say. Okay, we need to go quicker. So here, please chop it separately, like text and each line equation. Equations will be valuable. It's really cool that you write them, but in this format, it is hard to interpret, navigate, and discuss. So all this text should be editable.
Yeah.
And you were telling in private that you are working on a table. Okay, so we are done with the work of Mead and going to the work of Amir. And Mead, you see, the equations are really cool, but they are so bulky in this format that probably you did
Yep.
off everyone from reading further. So,
yeah, I understand it. This is his first attempt in my analysis of it. Yeah,
okay.
I'll put it into single form, like you said.
Super. Any quick questions to Mead? 1, 2, 3. Okay. No, then we'll go to work of Amir. Electronics. It depends on community.
Okay.
Here,
I think about this comment also before previous time. Even if the orbital are swept, so they are kind of new orbital. So how could we understand they are new, they are swept?
Oh, Amir, I'm not arguing with you. I'm at your side, whatever you decide to do. But we need to fight with future reviewer.
Okay.
And let me suggest an experiment in our brains. So do not do anything, just imagine. Suppose you redo the set of orbitals for each electronic configuration. Okay?
Okay.
As a figure. And now you compare the orbitals of neutral ground state and the injected configuration.
Mm-hmm.
If you will see that LUMO of the neutral and HOMO of injected look absolutely the same by the pattern of electronic cloud distributions, then we would say that it is the same orbital that just changed the population and slightly changed the energy.
Okay.
And I also have difficulties to describing describe this by words, but I would say molecules of the same, not molecules, orbitals of the same symmetry or of the same distribution of electronic clouds are the same orbitals.
Okay, got your point.
And anyone among us is welcome to suggest better word to verbalize it. And this comment is needed to all of us, especially later on when we describe non-adiabatic dynamics. When we run molecular dynamics, energy of quantum orbitals swap their order, but they like identity of orbital can stay the same. It changes its index and count in absolute way, but it's one needs to look on the symmetry of orbital. Okay, let's go further and see. Again, same comment in a different place. Aaron may have some suggestions or comments on this injected configurations because he is world expert in injecting charge.
Sure, I will ask. I don't.
Maybe everything is great and he will just share the encouragement, but this is probably irrelevant for the paper. I just wonder if the words of oxidation and reduction in electrochemical cell are applicable to use here. Maybe not.
I will focus more on them. I do not have a certain answer for you this time, but I will study more on that.
Nothing is wrong, but it sounds like not very confident. So let's read together maybe some basic literature like Wikipedia on the keyword.
Okay. Yeah, I just didn't address this comment previous time. I told you in the presentation. Okay. I will address that later.
Thank you. But it reads well.
Okay, I will revise that.
From this data in this paragraph, it doesn't look like we have absolute coincidence, but we are coming closer, and we have methods that get energy of the peak from the left and the right. So I don't know what is the next step, and probably no calculations are needed, but a comment, verbal comment can be added. For example, let me give an example without any consequences. Hartree-Fock method always gives overestimated bandgap. DFT gets underestimated bandgap. And then there is a little cheesy invention of hybrid DFT where one mixes energy calculation of pure DFT and Hartree-Fock in certain percents. And by this attempt, they fit predicted energy to be very close to experiment. In some sense, we could imagine making a mix of PBE and HSE06 with certain proportions that would ideally reproduce the energy. Maybe I'm saying something wrong and strange, but it's only food for thought.
Okay.
And I don't know if anyone read discussion. I left this pleasure for next week.
Okay, thank you very much. I will try to address the comments.
Yep, many thanks. And let's go to the work of Aaron. So I was trying to give any critical comments, but it was really hard because it reads well and consistently. I see some comments from previous iteration are taken care of. Let's check, maybe someone added more comments. No, I think, Aaron, I think everyone in the audience admires your writing, which, so it's good to go. And it will be really great if in the reasonable time frame these things get completed, either for this paper or the next one. Better this one, but whatever happens is good.
Mhm. I just started couplings and they're running healthily now. So it's a waiting game.
Excellent, excellent. We do not have substantial increase of the hours on our nurse account, but it looks like after New Year, the wait time in the queue became shorter. So anything we submit works within a day. And I do not know what we will be doing in the second half of the year, but I think it's an opportunity to compute things quicker and have things done. Well, many thanks for enthusiastic contributions. Let's focus on discussion. Oh, please consider to implement any changes from today, and we will not look on it until the whole paper is ready. But everyone is responsible adults. Just look at the comments, make changes, and assemble towards the final draft. Let me know if any emergent things need to be discussed. I'll probably postpone it to other time, but let me know if there are something. Okay, and probably I will find a way for freestyle discussion another day of the week, or maybe after we finish papers, but for next few, or in this semester, new wave of graduate students didn't found any available time other than Tuesday late evening. So I need to be in the online class in like 3-4 minutes. So I would really enjoy to have maybe informal chat, but we probably, I don't know, need to talk one-to-one or set second group meeting, or find some ways to have more communications, but I really need to go. So many thanks to everyone. I'll hope to share the recordings if anyone needs verbal voice comments. And have a nice.
Thank you. Thank you all. Goodbye.
Thank you.